Morning, students. Morning. Hello, morning. What am I sharing? What I was sharing?
Morning, sir.
Morning.
Okay, sure. All right, can you see the screen, right? Clearly, can you hear me? Can you see the screen? Hello.
Yes, sir.
All right. Good. All right. So we're off to a late start. We're very busy today, but I always say better late than never. All right, so I'm going to work some of the questions that I've been sending in the group, some of the bearings questions, and you're going to see that they are actually very, very easy. All right, I think I might need a calculator. That is tricks. Normally you need a character for the tricks. Just the character on the screen to the and make sure the character is in degrees. If you look up here, you'll see that it is in degrees. All right, so let's go. So this is the May 2024 paper. You can see it on the top line there. May 2024. That's the last exam, CSEC set. And this is a section 2 question. Question number 9. Question number 9, part E. So in section 2. And trigonometry in section 2 is always so let's say non-right angle triangle trigonometry. Trigonometry where you have to use the sine rule and cosine rule. Somewhere is internet not so stable. Yeah. Let me try again. All right. All right. So I was saying basically it's a section 2 trigonometry where generally speaking you have to use sine rule and cosine rule, right? And the application topic for the use of sine rule and cosine rule in CSEC is bearings. All right. So most of the questions will be bearings. All right, so the question said the diagram below shows a quadrilateral PQR formed by joining two triangles. These are two triangles, triangle PQR and QR. Can see the screen, just making sure. But we just lost contact a while ago. Everything good still on your end?
Yes,
All right,
yes, sir.
and that is it, right? And it wants us to calculate the length of QR. In this diagram, all the dimensions are given. So there was no need to put the dimensions in the wording. All right. So all the dimensions are given on the diagram. I want us to find the length of QR at this length over here. All right. So basically, we're going to be working in this triangle to find this length. Now, in this triangle, it is not a right angle triangle. Therefore, we cannot use so-called tower. We cannot use Pythagoras theorem. You have to use the sine rule or the cosine rule. Now, you use the sine rule when you have a pair of angle and side opposite each other in a triangle that you know both of them. You know the length of the side and you know the angle opposite to it in value. In this triangle, the one angle that we know, the side opposite to it we don't know. And so the sine rule cannot be used. And I always say, check if you can use the sine rule first. In fact, this triangle is a typical case for the use of a cosine rule. That's what you have is two sides and the angle between them. All right. And this is a typical case for the cosine rule. So we're going to be using the cosine rule to find this side. Now, cosine rule, there's a formula of what have you for the cosine rule, but you know, we tend not to depend on the formula. It'll be on a formula sheet, I think. It's on a formula sheet, but it's prefer us to learn to do it without depending on the formula. So I always say cosine rule starts out like Pythagoras' theorem. Treat this like the hypotenuse to begin with. It is not an hypotenuse, you know what I'm saying? You treat it like an hypotenuse, and you start out like Pythagoras' theorem as if this is a hypotenuse. And so if it was Pythagoras' theorem, if it was Pythagoras' theorem with this being the hypotenuse, it would have been that QR squared, the side that you're trying to find squared, will be equal to this side squared plus that side squared. 16 squared, 16 squared plus 18 squared. That is if it was a right angle triangle. So cosine will start out like Pythagoras' theorem. So this is what it would be if it was a right angle triangle. And this was a hypotenuse, but it is not a right angle triangle. So I always say you have to subtract a piece. So the piece that to subtract is twice the product of these two sides in the cosine rule and the cosine of the angle that is opposite this side, or the angle between those two sides, which is 25 degrees. All right, and then the Q, if you want it, you could have left off the square and put the square root over all of that. All right, but I'm going to leave the square now and write QR equal. Then I'm going to put everything here in the calculator and do one calculation. QR is going to be the square root of whatever this value is. All right, so I'm going to put it all in the calculator. So it's going to be 16 squared plus 18 squared minus 2 times 16 times 18 times cosine of 25. And that value is 57.967, if you like. And I was square rooting, so the final length of QR by square rooting this result. So we can actually put the square root over this expression that's on the screen. We can bracket the front, we can bracket at the back, and square root it. And that works down to 7.6. And I always give you an answer to 3 significant figures. I would put 7.61, and it is in meters. All dimensions are meters. That is it. Are you good with that? Are you okay with that?
Yes, sir.
All right. So always put what you find on the diagram just in case you need it again. So this side is equal to 7.61 meters. All right. That is it. The next thing I want is this. Oh, they give us some information. It says the bearing of P from S. I must always know a from position. The bearing of P from S is from S to P. The bearing is 205 degrees. The bearing is placed at the from position. They want us to determine the bearing from S back to R, from S to R. But let's put this bearing angle on the diagram first. From S to P is 205 degrees. S to P, the bearing is 205 degrees. All right? So the line from S to P is on a direction bearing of 205 degrees. Let's put it on the diagram, see? S and the P. This guy is saying that this direction is on a bearing of 205 degrees. But that 205 degrees must be measured at the from position S. So to populate the diagram with that information. So to show that bearing angle, I'm going to stand at S and face north first. I'm going to put this as my north direction. And then my bearing down to here into this direction, which will take me down to P, is the clockwise angle from the north line. So this whole angle here is what is equal to 205 degrees. That angle is 205 degrees. All right, I want it there from the north line clockwise. So you face north first and you turn to the right until you face them. So that whole angle is 205 degrees. All right. Now, based on the fact that this is 205 degrees, the entire thing is 205 degrees, and you have these two pieces in here, 72 and 25, we can actually find the angle inside here, which will be the bearing from S to R down here, this direction, which I think is what the question is asking us for. All right, so that's the angle that they gave us. But now they want the bearing from S to R. They want the bearing from S to R. They want the bearing at S down to R. Bearing must be measured at the front position. So that now is from S to R. What is this direction? What is the bearing of this direction? So this is the front position. So basically it is an angle inside here. So if I zoom it up, I should show you. It is a clockwise angle. This is the direction down to R. You want the bearing of this direction. So at this front position, this will be the north line still. It is a clockwise angle down to here. That is the angle that I want, which then is easily calculated because the entire angle around is 205, as I said, and you know these two. You're going to subtract these two from the 205 to get the angle inside here. All right, so let's put on the calculator. That's 205 minus 25 and minus 72. That angle inside is 108 degrees. This is 108 degrees from the bearing that I want. Things like that. So, throw some calculation down here. You can write it and say that angle becomes equal to 205 degrees minus the 25 degrees and minus the 72 degrees to give us that 108 degrees bearing. Very good with that? But okay.
Yes, sir.
The next part asking us to bearing from P to S. Always note the front position. So this is the front position from P to S. We want the bearing. So the bearing must be measured at P. That's a line from P to S we're looking at now. P to S. Let's look at the diagram now. So this is P and the map of the S. So they want the bearing now going this way. That's what they want. The bearing now going that way. But that's kind of easy from P to S. All right. So we're going to measure the bearing at this front position. Right in red. So again, at the front position here, you have to draw the north line. So face north first. The north line now at P is parallel to this one. Those two lines parallel. And you want the clockwise angle here. The line that will take you out to S from P. But this is the direction P to S. You want the bearing of this direction. And it is this angle. This is our north line. So how can we get this angle? Multiple ways to get that angle. What I would do is say, okay, this and this parallel, then it's a different color for this part. That and that parallel. Then the angle inside here and the angle inside here, they add up, which is the bearing angle, they add up to 180 degrees. So let's say we call this angle that we want, the bearing angle. Let's say we call the bearing angle theta. And let's say we're calling this angle over here alpha. Then the bearing angle that we want would be bearing angle theta will be 180 degrees minus alpha. Why is 180 degrees? Because these two angles are what we call co-interior angles. Right? It's like there are angles in this U. Parallel lines together with this line joining them forms a U, like a U looking thing. And the angles in the base of the U are supplementary. Supplementary means that they add up to 180 degrees. So these two angles add up to 180 degrees. All right, they are co-interior angles. All right, and so to find the theta, we need to work out what the alpha is up here. But the alpha here can be calculated easily because you already know the total angle around here is 205. And you should know that total angle around a point is 260 degrees. And if a part of it up to here is 205, then the remainder must be 360 minus 205. That means then that this angle right here is 260 degrees minus that 205 degrees. These are the only way to do the question, but I'm not showing you that way, right? I'm going to show you another way. I'm going to show you another way after this. That's 205 degrees. So I'm going to do it and do 360 minus 205. I'm going to get 155 because it's 155 degrees. And therefore, the theta angle that they want down here, the bearing angle that they want down here becomes 180 minus 55, minus this 155. This bearing angle becomes 180 degrees minus 155 degrees. We work that out. I'm going to do now 155, 180, 180 minus 155. That gives me 25 degrees, which I have to put 0, 25 degrees. But bearings must be expressed in 3 degrees. So that bearing angle is that angle right there, 0.25. But I go with that? But okay?
Yes,
But
sir.
Yes, sir.
watch this now. I'm going to show you another way to do it. I'm going to erase this off the diagram and show you another way to do it. Look at this now. I'm going to take this all off, show you another way to do it. Maybe I can undo what I just erased. All right? All right, let me show you what I mean. Then another way to do it. Watch this now. All right, let's go for the purple again. So the bearing from P to S, remember, bearing is a direction, right? You want the bearing of this direction, P to S. If I take this line PS and I extend it out here, right? So this line is extend PS out here. And this is still the direction of PS. You can get the bearing of this purple line, still good. All right. So that bearing angle, let's extend this for the purpose of this illustration. Let's extend this north line. So that's the north line. So the bearing angle that you want is the bearing of this direction, which is the same direction up here. So that direction of this bearing of this direction would be this angle that I'm marking purple right here now. This angle. And the north line clockwise to the direction line. This is the angle that you want in it. This is the same theta. So the question is, how could we get that angle theta from all of this information? How could we get it? Well, look at it now. All of the angle around to here is 205 degrees, right? But this piece right here, majority in blue, majority in green color. Right here to right here is 180 degrees, but that's a straight line. 180 degrees, straight line. So the whole thing around here is 205, but right here so is 180. So it means that the angle inside here, which is the bearing of this direction, becomes 205 minus 180. So this bearing angle could easily have been found this other way by doing this angle inside here would be 205 degrees minus 180 degrees. It's going to give you the same 0.25 degrees, which is 0.25 degrees. That will be a quicker way this time to do less calculation. So, in other words, the point is to get the bearing from here to here. It is not every time you have to absolutely measure the bearing at the front position. You basically measure the bearing of the direction. So if you can get the bearing of the direction at some other point, it will still work. Our bearing is the bearing of a direction, not just of a line. We're doing the bearing of a direction. Bearings are directions and not just lines. Okay? The bearings are direction. So every line that is parallel to this, even over here, is on this same bearing of 0.22 degrees, 0.25 degrees. But understand that? But I good at that?
Yes, sir.
Yes, sir.
Right. So I want you to practice doing stuff like this. I just did here. More things you know, the better. We want to do the mathematics the easy way at all time. This would have been an easier way to get the bearing from P to S. But just recognizing that the direction P to S is the same direction up here, same direction. And with all these angles that you know in this region, you just need to work out what this piece was and deduce it. All right? But that finishes this question. The angle is 0.25. So it becomes, in simple terms, becomes 205 minus 180. Simple as that. And it becomes 25 degrees. It is 0.5. But the way that I did it first, which was to come down here, put the north line, show that this angle you want, and all of that. Most persons will do it that way. Right? That is the go-to way to do it. I'm just extending your knowledge. More things you know, the better. All right? Develop your skills. All right. And that should also help you to understand the concept of bearings being a direction. Bearings really is a direction rather than just a line. Right? The bearing are just angled to a line. Bearing is angled of a direction from the north line. All right. How to go do that? Now move on to the next question.
Yes, sir.
All right. God also gave you January 2024. I don't remember what I gave you. I'm just gonna work backwards, right? But I think I also gave you January 2024 to do. I was gonna do a number of questions, maybe for 1.5, 2 hours, and then we'll call it a day. Because all these questions, you're gonna have to do them again. All right. So just remember that. You're gonna have to do all these questions over again. So doing them now doesn't mean it's the last time you're gonna see them. We're gonna have to do them again under exam conditions, and we're gonna do them again. We're practicing again and revising and stuff. So it is more math equals better math. So you have to practice a lot. I have to do the same question 5, 6, 7, 8, 9, 10 times until we get it right. Understand it fully. That's what we will do. That is what we will do. All right, so this is the 2024, January 2024. So last year. And let's see, surveillance system, surveillance. I don't think I gave you this one, but this one had some elevation in it. I think this one had some elevation. Let me see. This one had some elevation. See, there's some elevation, and we don't have the elevation yet. So I don't think I included this question. See, the angle of elevation. I don't like to set questions and stuff that we have not yet done in class. All right, you it's not difficult, easy, but you know, so we're not gonna do this one. So this one is a combination of elevation and bearing. That's what this one is. All right, so because we don't do the elevation yet by itself, I'm not gonna do this question. Let's leave this one. All right, let's go to 2023. Okay. So we'll come back to this topic, this question after we do topic of elevation, which is tomorrow. All right, 2023. 2023 January. Let's see that one. Do this one now. Here we go. So that is one of the questions I gave you. All right. So another tricks question in section 2. We don't have any right angle triangles. You have to use sine rule, cosine rule to do it. All right. You cannot use so-called or you cannot use Pythagoras theorem. Question says the diagram below shows 4 points, P, Q, R, and S, and level ground. Where pillars mark the outline of a foundation. Oh man, the elevation in the that's this is a vertical pole RT, right? Here is a vertical pole. So I don't want to do this question here. Even over this one. Once it has elevation in it, I'm not going to do that. Let me see if there's a part of it that leaves the bearings only. So given that Q, so that I take the perimeter foundation. Oh, this one I should not have given. If I gave you this one to a mistake, I don't know. Did I give you this one to do? January 2023? This one is more elevation question than a bearings question. So sorry about that. I didn't give you this. Okay. All right, good. All right, so we'll do this one. We'll do it after elevation. All right, so let's look at mean 2023. All right. Looks like a straight line. All right, let's look at this one. So this one says, the diagram below shows a triangular field L and P. So the field, so it's the distance in meters. So it's a field, the distance will be in meters. For a city, the distance will be in kilometers. That's how it is. If there's something on a piece of paper, the distance would have been in centimeters. All right. So that's how the scale of measurement I use. All right. It says calculate the value of angle MLT. So you see all the dimensions are on the diagram. And they want MLP. So this is an example. They give you 3 sides. And so you have to use cosine rule to find an angle. Once you're given 3 sides, you're going to have to use cosine rule to find an angle. All right. You just know who is about it. Which angle do they want? They want angle MLP, the angle at L. Let's call it theta and show it on the diagram. So it's asking us for this angle. We want to use cosine rule. So we want to treat it as if we have these 2 sides, the angle between them this way, and treat this over here like the side opposite the angle. Treat this like hypotenuse to begin the cosine rule. Remember, the cosine rule starts out looking like Pythagoras' theorem. So you're treating this now as the side that would have been hypotenuse, that would have been opposite them 90. If this was a 90. But because it is not a 90, you have to subtract the piece from the calculation. All right? That's the way to look at it. So we're using cosine rule to do it. Cosine rule. Cosine rule for the theta. Now, you can get to a level where you can write the expression one time, you know, right? But let's say we don't reach that level yet. So we're going to set it out as a cosine rule normally. So the side opposite over here, treat it like an hypotenuse to begin with. I'm not saying it is an hypotenuse. Only a right angle triangle has an hypotenuse. But I'm just saying for the cosine rule, it starts as if this was an hypotenuse first, because this cosine rule starts out looking like Pythagoras' theorem. So it would have been 180 squared equals this side squared plus that side squared. If it was Pythagoras' theorem, 150 squared plus 120 squared. But because it is not a right angle triangle, it is not Pythagoras' theorem, it is cosine rule. So you now have to do the subtraction part in the cosine rule, which is to minus twice the product of these 2 sides, the 150 and the 120, and then take the cosine of the angle between them, which is theta. So now it's like you're transposing to make theta the subject. Now with practice, you can actually look at this and do it and write it in one step. With practice, but I'm going to show you the steps this time. All right? All right, so the first step is that this whole thing is coming over onto the right side and change the positive, and this 180 squared is coming over onto the left side and become negative. That's the first step. All right? So I can literally just copy this whole thing and just move it piece by piece. Look, I'm just copy this whole thing and just move it piece by piece and show you. All right, so what I'm going to do, I'm going to take this over here, that is negative. I'm going to take it over the other side, it's going to become positive. So this will move and become positive. I'm get the word on this side, bam over here. And then this now, this over here, I'm going to come on this side and take up the negative. All right, so I'm showing you the transposition step by step. So this thing now will transpose to this side and become negative. So I'm going to slide this down a little bit closer. Then this now, you want to move this product, those 3. What happens is that these 3 will divide under this side. That's like you divide in both sides by. So I'm going to draw a line here now. Take these 3 and then divide them under this side. That's what you end up with. And then now, because it is cos theta, that is equal to that. It means then, I'll show you further that the theta, then to move the cost, we take the inverse cost over here, and the inverse cost is cost to the minus 1 of everything. And you have to calculate like that. That's how the transposition goes. And then just putting everything here in the calculator. Now with practice, you actually will be able to just write out the whole of this from the get-go. Or if you write this first, then you write that. But some persons practice to a point where they can literally just write this from the get-go with practice. But the format of the result is always the same. All right, so I'm going to put everything right here in the calculator. I'm going to go cos to the minus 1. I'm going to put a fraction in there. I'm going to put a 150 squared plus 120 squared minus 180 squared. And I'm dividing that by 2 times 150 times 120. I'm getting 82.8 degrees. This answer is 82.8 degrees. 82.8 degrees. As always, if you find an angle, you put it on the diagram. So now know that this angle inside here is actually 82 and 8 degrees. This angle is 82, 82.8 degrees. That angle right there. What are we going to do that so far? But okay?
Yes, sir.
All right, so look at this triangle now, right? Look at this triangle now. The only thing they don't know, you know, the 3 sides, and you know this one angle. The only thing you don't know in this triangle right now are these 2 angles. And any one of them you want to find, you can now use a sine rule because you now have this pair of angle and side opposite each other where you know both of them. And so going forward, you can use a sine rule because that's what you need to use a sine rule. A pair of angle and side opposite each other in the triangle where you know the values. You know the angle and the value, and you know the side, you know the actual length of the side. Down here now, it tells us a bearing. It says the bearing of P from L. Always take note of the composition. It's from L to P. The bearing is 210 degrees. I want to show this on the diagram. Show that bearing on the diagram. That's L to P we're talking about. Bearing is 210 degrees. L to P, the line from L to P is on this direction. Remember, bearing is just a direction. L to P. All right, let's put on the diagram. So it's L down to P we're talking about. So this line, this direction is 210 degrees in bearing. All right? So is that direction measured in bearings? The angle is measured at the front position, which is L right here. Now the L put at the point L, you have to face north first. And that's a north line that is given to us. It is talking about this angle clockwise to the line that is taking the bearing direction up and bearing direction to the bearing angle to that direction is that angle. That angle is what is 210 degrees that I just gave us. This angle is 210 degrees. Let me draw it a little bit wider. This whole angle is 210 degrees. And inside there is 82. So we basically can work out this one inside here, which is now the bearing down to here, L to M, is now 210 minus the 82.8. I think they're going to ask us for this angle. Let's look at it. So they give us that bearing and we show it on the diagram. We show the angle on the diagram and see what I want now. The bearing of M from L. See? From L to M. We want the bearing from L to M. L to M. That's the bearing that I want. The bearing of that direction. That's the same angle that I just said. Right? The bearing L to M. So L here to M here. We want this direction bearing, which is this angle inside here. Right? Clockwise from the north line. They're trying to find this angle in here, which becomes equal to 210 minus 82. No, minus 82.8. Right? So this angle inside here comes 210 degrees minus 82.8. But bearings, I give it to 3 digits. So I work it out and I get the answer, I give it to the nearest whole number, 3 digits. Right? So it's 210 minus 82.8. 127.2 degrees. I'm going to put 127 as a bearing. So the angle is 127.2 degrees. But for bearings, you just give them this. All right. So let's put the calculation down here. So to work out 127 degrees of the bearing. And calculation is on the diagram right here. Calculation is here. So they would say you get 127 on the diagram. That is that. Next part now says calculate the value of angle NLP and hence find the bearing of L from P. So now they want the bearing from P to L. That's P to L. They want the bearings. All right, but first I want us to calculate the angle inside here, the angle of L. Let's call that angle alpha. We call one theta already. Let's call this angle alpha. Put it on the diagram. The angle of L. Angle of L. That's the angle NLP. Okay. It's actually the angle right here. The one. Let's put down a different color. Let's put down in blue. Right? NLP. Let's make sure. Yes, NLP on the diagram. Which is the angle over here. The one. Down in blue. I'll put down a different color. Let's put down in blue. This angle, which is not a bearing angle in the diagram. Let's say it is where's the must to find it? So that's the must. Oh, calculate it. Good. All right. I want to find that angle now. I'm gonna say it is alpha, right? That is the angle alpha. So no, that's easy to find because total angle around the point L is 360 degrees. All of this up to this line is 210. The remaining piece in here, alpha, becomes 360 minus 210. So this angle that I want must tell them is 360 degrees minus 210 degrees. All right, 360 minus that becomes 150. Becomes 150 degrees. That angle is 150 degrees. And then now I want the bearing from that information now. After we get this, it's a hence. Hence means you have to use that result to get the bearing of L from P. P to L bearing the one. P to L. So P to L now is this bearing the one. P to L up here. So P up to L, this direction. I want to bearing of this direction. P up to L. All right. And ask us to find it after finding this. Maybe we could have gotten it here as well now. So this angle. All right, that angle there. So we need more information to get it on that side. So the easier way to get it this time is to get it from down here. So that if you're in this direction, you'd have to draw the north line here first and draw it in it at the front position. And it is clockwise angle the line going out from P to L. The question is asking us for this angle now. What it is that these two angles now are co-interior angles. They are at 180 degrees. This and this. But there are angles in this U looking thing, and the different color. Angle inside this U looking thing. This angle and this angle. They are co-interior angles. They are at 180 degrees. And this part of it up here is 150. The part down here, the one must be 150 minus 150, which is 30. So the angle inside here will become 180 degrees minus 150 degrees. The angle is actually 30 degrees. For the bearing, you have to put a 0 in front of it for the bearing. So the angle is 30 degrees, but the bearing becomes 0 30 degrees. This is the bearing angle. So when I write it down here, this angle becomes 0, 30 degrees. Well, angle NLP is 151st. Angle NLP 150 degrees. It means bearing angle, bearing angle, bearing L to, no, P to L. Bearing P to L is 0, 30 degrees. That will become 180 minus 150 is 30 degrees. Then put the 0 down, 10 of 3 degrees. That is it. Very good. Okay, guys. Hello, hello,
Yes, sir.
hello.
Yes, sir.
All right. Remember, any question get wrong, you go and redo it. Any question get wrong, go and redo it. All right. Any question get wrong, you do it over. Do it again. All right. That's 2023 June. All right. It's not January. So I'm going to go to 2022 now. 2022. 2022. I'll see June 2022. So that's it. 2022. There we go. All right. So this question gives us this diagram here and gives us some information. It says the port L is here. From a port L, a ship R, so the ship is the R. Ship R from port L, ship R is 250 kilometers. That's this. And it's on a bearing of 065 degrees. So this direction is on a bearing of 065 degrees. Let's just put on the diagram from now. So this is the from position L is an which I will turn to the right to face the direction out to R. It is this angle that will be fixed on there. That 065 degrees. So this angle is 065 degrees. All right, that's that. This is also 250 kilometers, but that is on the diagram already. Then now, ship T is 180 kilometers from the same end as this. And that one is on a bearing of 148 degrees. That's the bearing of this direction. This angle around here. Clockwise from the north line at the front position, that is the bearing angle. Just put on the diagram. And then this angle around here is 148 degrees. The angle between these two sides becomes 148 minus 65. I'm sure you're gonna need it. Work it out from now. The angle inside here becomes 148 minus 65. 148 minus 83 degrees. So I'm gonna say there is 83 degrees. All right, so I'm sure they're gonna ask us for. So give us that information, right? It says complete the diagram above by inserting the value of angle RLT. Yeah, that is it. So insert it, that is it. All right. Then now, I got this angle by subtracting 148 degrees minus 065 degrees. This is how we got the 53 degrees. It says calculate RT, the distance between the two ships. So it's now asking for this distance over here. It's kind of easy because we now have two sides and the angle between them. The cosine rule will give us this length over here that I want, cosine rule. So let's set it up. So we can put the square root on it now because it could have been RT equals RT squared, sorry, equals this side squared plus that side squared. That's 180 squared plus 250 squared. Then subtract twice the 180 times the 250, and then times the cosine of the angle between them. Is here through the base. Then now, we will work this out and then square root. So what I'm going to do, I'm going to take off the square and the square root is one time. I can actually practice it, practice doing it that way. So I'm going to take off the square and square root all of it. And put that in a calculator and get the RT in one step. So go from the square root and it is squared plus 250 squared minus 2 times 180 times 250 times the cosine of 2. It becomes 289, 590, 290 kilometers. But I said that calculation. Gotta go with that.
Yes, sir.
Yeah, sure.
So,
All right. So then now they want the bearing of T from R. Let's look at it again. Let's look at the habit of marking it from position. Very important. It's from R to T, to the line RT. We want the bearing of the diagram, direction RT. We want the bearing of. So let's put on the diagram and then get that bearing angle. Angle must measure at the from position. R to T. Like R down to T. They want the bearing. So I want the bearing of this line. R to T. So let's put on the diagram on this side open and find it, right? But by the way, we now know this distance. So let's put it on there. It's 290. I always put up a fan in the diagram. This side is now 290. 290 times this side. All right, let's mark the bearing that I want. R to T, right? Let's put on make sure again. Bearing of T from R, right? R to T. On this diagram, the one is bearing, the one is bearing of that direction. Let's mark those. So at the front position, let the face north first. All right. And I always tell the students, if they want the bearing at this point, 99% of the time, the angle inside the triangle, here I'm calling alpha now, will play a part in the calculation. All right? Will play a part in the calculation. All right. So the bearing angle that they want is actually this angle only. It's not just a straight, not line. I want it to look. Nice. So the bearing angle that the question wants us to find, let's put on the purple. This whole angle around here. That's the angle that I want us to find. All right, that's the bearing angle. But there are multiple ways to do this. All right, there are multiple ways to do it. So the fact of the matter is that you know that this angle inside here so is 65. All right, and then if you come up this line, go down this line, and go down this line, then all this is also 65. Maybe that's I'm looking at another way to do it, right? Or I can just go into the angles and get here, find the alpha, and then you can find the theta with the bearing angle I want. You can find this angle by getting from the 65 Then I know that I'm going to need the alpha using cosine rule, and then the bearing angle kind of point. So total angle on the point is 360. So I'm looking at another way of making this angle, the vertical line, like so. But up here is 180. Question will be what is this angle here? The whole of this angle will be 65 because of the Z. So the Z here now, down there, up here, down there. So all of this will be 65. All right. And then you can get the alpha as well. So multiple ways to do it. So what it is that we can say 180 up to here, 180 up to here. Then we have to find this little piece by doing 65 minus alpha. So anyway, you're going to use this angle. All right. It's just a matter of deciding which method to use. All right. So let me use the method where we just do the total angle around the point this time. All right. And the alpha will come into play. So the first thing is questioning what is this angle? I'll mark out the two angles in green. So this angle that we want now, we mark in green, is supplementary with this 65-degree angle. I see there are angles in this U. This angle and this angle add up to 180. It means that this angle inside here is 180 minus 65. 180 degrees minus 65 degrees. This is the easiest way to do it. 180 minus 55. It's 115. This is 115 degrees. And then now, we need the alpha as well. If we call this bearing angle theta, we must build it up. Let's call this bearing angle at the one theta. The one to find theta. So look at it. The theta is 360 minus the 150 and minus the alpha. So total angle around the point is 360 degrees. And so the bearing angle here, which is the theta, becomes 360 minus the 115 and minus the alpha. So I have to find the alpha same way. Let me write it off for you. The bearing angle theta is going to be 360 degrees minus 115 degrees minus alpha. I'm going to use sine wave for the alpha. That is it. Everybody see that? Everybody see that?
Yes, sir.
That is good. I'm going to use a sine rule in there. We're going to cross them, right? Remember you're crossing them. So using this pair with that pair. All right? The sine rule. Using this angle with that side and this angle with that side. With the sine rule to find the alpha. I can tell the speech right on the screen just to have it in front of you. So the sine of alpha, sine root for alpha, sine root for alpha. That's talking here. It's right in front of you on the screen. So sine root for the alpha. Let me do that. Sine of alpha over the side opposite the alpha, which is the 180, is equal sine of the angle that you know, which is 3 degrees. Over the side opposite the 3, which is 290. Then to transpose this, I want to take the 180, multiply it up here, and then the inverse sign in front of everything. All right, so the alpha becomes sine to the minus 1 of the 180 multiplied up here. Always put the multiplying value in front of the 3. So 180 and the sine of 83 degrees divided by 290. And that's what we're looking at for alpha. So we can actually, let me shift this up a bit. So the alpha becomes, where that out. We're going to need it, so it becomes sine to the minus 1 subtraction, and it is 180 times the sine of 83 over 290. So it's 38. Let's write 38 degrees. So 38 degrees now is coming right here. Look at that here. So here we do the over. And I spell the examiner. Do everything on the diagram. So the bearing of T from R is equal to theta on the diagram. Right? The theta, we said is 360 degrees minus the 115 degrees minus the alpha. It says something like where the alpha is using sine rule. And you do the calculation if I just click here, copy it down, then the same calculation that we just did. Copy it, put it here for the sine rule. And you take this 38 degrees and use it back up here. So that angle theta becomes 360 degrees minus 115 degrees minus 38. Make it again that way. So it becomes 360 minus 115 and 470. Is it 170? But good at that one. I like this one. I like this one a lot. Okay with
Yes.
that one, guys?
Yes, sir.
Yeah? All right, good, good, good. Let's see. That is 2022, June. I forgot January 2022 now. January 2022. The master come around. All right. Now just about an hour. All right, let's go. Then now we're going to look at January. Question finish? Yes, just like that. January 2022. Remember, any question I got wrong, redo it. I'm going to send the video in the group and you'll use the video to help you. I'm going to send you this video. This video can get it there. So I want to redo the question, especially when the one that you got wrong. See, this topic is almost on every paper. You have to master it, all right? You will have to skip this one already, you know, but this one I went elevation. Okay, no. This question is straight. Here, no elevation. Let's go. Question says, diagram below shows straight roads connecting two connecting towns L, M, N, and R. L, M, N, and R. These are some straight roads connecting them, right? And we have some distances and some angles. All right. It says, so when you're reading up here now, guys, you're looking to see if there's everything that they have said is on the diagram. So that way you don't have to come and read anymore. You just work straight on the diagram. All right. It says LR is 18. That is 18. That's on the diagram. LM is 12. That's a MN is 10. That's right here. And RLM is 25 degrees. That's 25 degrees here. The angle up here, LMN, is 88 degrees. And then they gave us this angle, which is a bearing angle. This is the bearing of this direction from L to N. 50 degrees, 50 degrees. All right, but let's see what they say. Let's calculate angle MLN. Where is that now? MLN. Where is that angle? Angle at L. M to L to N. I want us to tell them this angle right here. Let's give it a name. Let's call it alpha. I like to reference things in questions. It becomes easier. I love to write in a lot. Let's call this angle alpha that I want. So I'm working in that triangle. It's not a right angle triangle, but we're blessed that we can use sine rule. Why? Because we have this pair of angle and side opposite each other. We know both of them. So sine rule can work in that triangle. So when we're using that pair with this pair in the sine rule, find alpha. All right, so sine rule find alpha for us. So say we call it angle alpha, and we tell the examiner sine rule for alpha. Sine rule for the alpha. So since that angle that we want starts with sine of the angle that you want, so it's sine of the angle that you want over the side opposite the angle. Opposite the angle is 10. Equals sine of the angle that you know. The angle that we know is this 88 over the side opposite. So the sine of 88 degrees over the side opposite is 12. And then you want to make this a subject. So again, you're going to multiply by 10 and then tell the inverse sine of everything. All right, so the alpha is going to be sine to the minus 1 of the 10 times the sine of 88 degrees divided by 12. Put this in the calculator now, let's see what we get. So it becomes sine to the minus 1, a fraction, and it's 10 sine 88 dividing all of that by 12. It's 56.4 degrees. 56.4 degrees. We're going to choose the calculator for one decimal place. And as you find it, put it on the diagram. All right, 56.4. I'm going to write 56.4 degrees right here. All right, so now know that angle. What else? They want the distance NR. Let's look at the diagram. NR. That's this distance. Let's get that distance going to work in this triangle. And this time now, we're going to use cosine rule because they say they could not make it work in this triangle again, you know. If they wanted to use cosine rule, you know, say they have to give a different triangle. Because once you start in a triangle with sine rule, then you can finish with sine rule. Anything else you want. The only thing that is left in this triangle that we don't know would be this angle, which you would find by subtracting these two common into. All right, so I put in a different triangle because I wanted to use a cosine rule. I want to use a cosine rule because the one angle that I know, I don't know the side opposite. Or I could say this is a typical case for the cosine rule. Two sides and an angle between is a typical case for the cosine rule. All right, let me do it right here. So cosine rule for the NR. That like Pythagoras is theorem. NR squared equals this side squared plus that side squared. 12 squared plus 18 squared minus twice 12 times 18 times a cosine of the angle between them, which is 25. And instead of putting a square here, we could just square root everything and leave off the square. And then let's put this in the calculator. This thing in the calculator. So we're going to get the square root. 100 squared is 12 squared plus 18 squared minus 2 times 12 times 18 times cos of 25 degrees. That's 8.7. 8.75. That's 8.75 kilometers. 3.75 kilometers. This is a 5. That is it. So we can copy this down to that page. Show how we get the NR. Okay. And down here now, I want the bearing to determine the bearing of town R from town L. So note again, from position it is from L to R. So L R1. So when the bearing of the line L to R, let's look at it. L to R. L to R direction. L to R. So on this bearing down here. Easy on this diagram. All right, because see the north line at L here, clockwise angle one, which is the sum of these. All right, so bearing L to R is the same of these, this plus that. This angle. Bearing R from L is 50 degrees plus the R point is 3 to 6.4. About that plus 66.4 plus 25. After the cars, it's just a minute car. It's 25. That's 131. 131.4 degrees. But that's being just put it as 131 degrees. Here, just choose it. H. But after that,
Yes, sir.
it's my second, let's pick a quick car, right? Second. All right, guys, I'm back. Sorry about that. All right, I think okay, maybe do one more call today. All right, as I said, we're gonna be doing all these questions again repeatedly. So I will actually start really late and I'm still busy. So yeah, just about an hour now, but let's just do one more and then call it again. All right, we're gonna do all of them again anyway. I don't know if I did the, I think I did the May 2020, May 2021 a while ago. Let's look at 2020, no, 2022, let's look at 2021. Let's do the 2021 paper here. You see that the bearing system come almost on every paper. So it makes sense to learn it properly, right? And we do that and practice it, master it. All right, let's see. 2021 paper. This is the January 2021 paper. Let's see. Right. Good. So this looks like a nice one. This question says from a harbor H, the bearing of two buoys, S and R, are 185 and 311. So I like these big angles in this example now. So they show the 185 on the diagram, but not the 311. All right, so the bearing from H, the first one S, is 185. So those two mean, right? So it is that the 185 relates to the first thing, the 350, the 350 relates to the second thing. Like I said, that's what I mean by respectively. So let's show the 185 on the diagram first. See, it's a clockwise angle, this is the north, and a clockwise angle to the direction that will take it down to S, the direction line will take it down to S. The 211 now is direction line, bring up this direction line up to Q, which is all of this angle around here. So now that is the 311 degrees. And I'm sure they're going to want the angle between the two sides in here, which should be the 315 minus the 185. All right, so for to show it, let me see what I want us to do. It says on the diagram below, which shows a sketch of information, insert the value mark angle QHS. This is angle that one. QHS. So they're asking us to put the value of this angle on here. This angle. That angle becomes 311. Why is it 311? Remember the bearing all the way around to here is 311 degrees. And then up to here is the 185. Right? Up to here is 185. So in between here then is what I want. It's 311 minus 185. All right, so let's do it here. So 311 minus 185, 126. Inside it becomes 126 degrees. I can show you get it out here. You know, put the calculation on the paper. Let me see. 311 degrees minus 185 degrees equals that 126 I'm putting on my diagram. That is it. Very good. But okay with that?
Yes,
Yes, one more.
yes.
Then no, they said QS, we have to calculate the distance QS, distance between the two buoys. So I guess I've given us some distance that I'm not put on the diagram. So I say, oh, so them here, the distance is there, these two distances. So which one is 5.4? It says Q is 5.4 from H, 5.4, and S is 3.5. This one is 5.4 and 3.5. Let's put them on. This one is 3.5. This one is 3.5 kilometers. This one is 5.4 kilometers. And the question down, again asking us for QS, which is now this side. Cosine will again, because we have two sides and an angle between them. Cosine will again, let's just do it right here. Because cosine will for QS. Erase everything. You want to erase everything. Cosine will for QS, right? Let's do it and copy it down. Cosine rule for QS. That's what like character is the same as usual. QS squared equal this side squared plus this side squared. 5.4 squared plus 3.5 squared was actually not part of the same, so we have to subtract that piece, which is 2 times 5.4. Shift this down here. All right, 5 times 5.4 times the 3.5 times the cosine of the angle between them, which is 126 degrees. That is a calculation. I'm just going to copy it down now to the next page. Copy it down to the next page. And finish the calculation here, which basically, as I said, we could have left off this square and a square root this. Let's just do that. Improve, put down a number of steps that we have to use. The QS that way. It's going to be the square root of 5.4 squared plus 3 plus 3.5 squared minus 2 times 5.4 times 3.5 times cos of the angle between them is 126. I give us 7.98. 7.98 kilometers. It's kilometers and meters. Kilometers. Then I want the bearing of S from R from Q. So it is from Q to S. Q to S. Bearing that one. Let's put that in the diagram. Let's look at the diagram. See what angle it is and then do it. Just Q down to S. I want the bearing up here. So. All right. So I want to bring up this direction. Q down to S. So at the front position, I have to draw the north line. So I set it up and show the angle that I want. The angle that I want is this angle here. Let's call that angle theta. You can reference it, right? Because as usual, the angle inside the triangle will play a part in the calculation here. I expect it to. This angle inside here. I'm going to call it alpha. I could put it inside here if you want to. All right, let's put it there. Alpha will play a part in the calculation. So, how are we going to get that angle theta now? Using alpha. So to do that, we could maybe know what this piece is. This piece right here. And theta will be this piece plus alpha. Now, this piece right here is co-interior with this piece right here. All right, that is co-interior with that. We also set up as V. Right, so down this one, and down this one. So you have to know all of this. All right, I think the co-interior is the best because the thing is, I'm treat that bit another way. Let's get it another way. Let's get it another way. Show another way. Another way. All right, let's look to use another way. All right, I see a way to do it in about it involves finding this angle. Basically, it's 311 minus 360 from 360, right? Gives us this angle. Then now we would use the north line. So these two angles now are up to 180. I will put on this angle now and then add it to the alpha. All right. But let me see if there's another way. That we could do it. Because we want the bearing of this direction. All right. Since about a lot of angles around here, we could maybe figure it out by extending this direction down here to the same direction. Look at it. All right. So instead of trying to work it out up here, this is the direction that we want to be here. So we could take this direction and extend it out here. the same direction. And then bearing angle that you would want would just be this angle. That angle we want. Alright. So it kind of becomes easier, I think. It's easier. So I want to bring of that correct angle. So we want to find this angle. Alright. So could get that angle now. So that angle we want, remember everything around here, so it's 315. All right, this is a straight line. So it becomes 350 minus 180. So easy that was. All right. But you can see that? See that, guys? But everything around here is 350. Everything all the way around here to the other end of this line is 350 degrees. Of that 350 degrees, I can show you what is one thing. This piece up to here, 15 inside here is 180. I put it in the USB. You see it, and look at these skills inside here is 180. The whole thing in red is 315, which will be the sum of the angle that you want right here, so now, and the 180. It means that the angle that you want, you should use a different color, you know. I think it should be better for this color. It's about 40 green. If I inside here, so from here to here is 180 degrees. That's a straight line. 180 degrees. And the whole thing around here, so it's 315. So it means that this purple angle that we're trying to find, the bearing angle that we're trying to find, the purple angle is 350 minus 180. Let's call that purple angle theta. This purple angle inside here, so let's call it theta. So the theta angle is 315, 311. This thing is 311 as the bearing all the way around here. Theta becomes 311 degrees minus 180 degrees. That is that bearing angle. P11 minus 1 becomes 131 degrees. But you can answer, I'm going to show you the other way now. I'm going to show you the way by doing it up here. But note that the answer, we got this answer easily down here by doing it that way. But you can see that? But understand that part?
Yes, sir.
Understand that. All right. So let me do the bearing now another way up here, which is going to be a more lengthy process, more calculation. It's much easier down here. So sometimes the calculation is much easier here than up here. And why is it more easier down here? Why it is easier down here? Because you have all these angles to work with. You have a lot of the angles around this point to work with. Right? So all I need to do is, because I want the bearing of this direction, I just extend it through this point. I know that I want the bearing of the same direction to this line. That's the direction. Remember, bearing is the bearing of a direction. All right. Well, let me redo it now up at this point and show you the steps that you have to take. Right? I'm always looking for the easier method, but I have to learn all the various ways to do the question. All right. So let me leave these on the diagram and let's do it up here now. Look, let me do it up here and show you and get the 131 another way. Then put in back the north line there at the front position. If you want to say, okay, you want to be being from Q to H, right? It's Q to H I want it. Hold on, I may find the wrong angle now. It's QH, let's see. I want Q to S. The wrong way I find, man. I just found Q to H, guys. Q to S them want. Q to S, this one what they want, Q to S. I calculated the wrong bearing a while ago. But if they wanted Q to H, that is what it would be. I was calculating the wrong bearing. All right, so it's Q to S that they want. My mistake. Q to S, which is this direction. All right, so we're going to try. So we're up here. I just did something that to maybe help you to understand if they wanted Q to H, what they put do. So let's go back. They want Q to S. That actually calculated the wrong bearing. All right, so they want Q to S, which is this. That's the angle that they want. All right, Q to S. Let's go back and scratch. Let's maybe we can avoid the length to work. The north line, the bearing that they want is this angle. Know that the angle inside here, take a part in the calculation. Let's just call it alpha from now. Alpha inside here. And we're going to call the bearing angle that we want out here, so theta. All right, and theta would be equal to that angle alpha plus this angle in here. So I'm going to mark in green. Theta would be this angle plus the alpha. What do you know about that angle, that green angle? Let me take this out. That angle, I'll put this line in red, this not line in red. Then this not line and this not line parallel. All right, so this angle inside here, so I'm going to mark in green as well. Those two green angles are co-interior. They are 180 degrees. All right, but this one down here, right? This one down here, this green angle down here, I'm going to do the 5.4. This green angle down here right now is 360. Is 360 minus 315. Remember that 311. Remember that the entire angle around here was 311 degrees. So this little piece is what is left from the 360 degrees. So it is 360 minus 311. 360 minus 311 degrees. It works out to be what? 360 minus 311. That's 49. And then now the 49 and the angle up here is support interior. So it means that this other green angle inside here, co-interior with the 49, and they are supplementary. So this other green angle up here now becomes 180 degrees minus 49 degrees. Work that out. 180 minus 49, we go 131. This is 131. The same 131 that we found down here a while ago. We got this bearing, right? Bearing of that direction. Same 131. But we really want the bearing of this line down here. So we really want the bearing of this direction. This direction. We want the bearing of this direction. That takes it down to S, which is some of these two. So still have to go and now find this alpha inside here. Can't avoid it. So if we come back in the triangle now, work out the alpha. So we're gonna have to populate by the diagram. This side, the angle side there was what again? The angle side here was 126. So 126. The side across from it that will form only the sine rule on the side across from the picture. That was QS 7.9, 7.89. This side came out to be 7.89 kilometers. and this was 5.4 kilometers. But to find this angle alpha, we're going to use it, the alpha with this side across here and 126 with that. I have to get alpha. Sine rule for alpha now. So when we sine rule for alpha in purple, sine rule for alpha. It's going to be sine of alpha over side opposite the alpha, which is the 3.5, equal the sine of the angle that we know, which is the 126, over the side opposite the 126, which is 7.89. And then I want to find the alpha. I'm transpose make alpha the subject, right? So the alpha is going to be sine to the minus 1 of 33.5 and multiply that here. We're going to get 3.5 sine of 126 degrees over this 7.89. Right. That. They report this for alpha, this calculation for alpha. So we're going to do sine to the minus 1 of a fraction. And it is 3.5 times the sine of 126 over 7.89. We're getting 21 degrees. And so the bearing angle theta becomes 131 plus 21. So that is it. The bearing angle theta. The one down there becomes 131 plus 26. The bearing angle is theta 131 plus 21. 131 plus 21. Plus 21. So that angle becomes 152 degrees, guys. I'm just looking at the diagram now to see another way to do it. So I'm going to slide the 152. I think that's the best way. That's the best way. That's this side, this direction. I don't know anything about this angle. So I guess it wouldn't do it in a shorter way. In the method they choose to do it, it's going to be rather lengthy requirement number calculate. And because it's on this line. If you want to do that line. All right, guys, that's it. Very good. That is it. That is it. That is it. All right, so a question like this, I'd advise to do it over again. Do it over. Do it again. More maths equal better math. Practice. Practice, practice, practice. This one forces you to use co-interior angles. You have to use sine rule. You have to use total angles around a point by 360 to get the little piece inside here. That's for the last question. Number of things you have to consider. The very last part. There's so much math to do for the last part. 3 marks, right? But that is it, guys. I'm gonna stop it there now. I'm gonna stop it there. But all right. You good?
Yes, sir. So,
All right. So remember now, you have to write questions over again. But that's foolishness. Just put the questions over again. More math equal better math. All right. Practice. All right, guys. So see you after the 1 hour 30 minutes. All right. See you in class tomorrow. We're gonna be doing elevation and three dimensions, trigonometry. Trigonometry of three-dimension situation. So combining elevations and bearings. And just three dimensions, trigonometry generally. I'm to do that tomorrow as well. Wednesday's classwork, finishing with trigs this week. And I'm starting to prepare next week. All right, so see you all in class tomorrow on Monday. Bye, everybody. Want to send a video in the group, you make sure you practice question over again. Anything you got wrong, you redo it. That is always the rule. All right, bye, everybody. Bye.
Bye, sir.